Hello everyone. So today we are going to talk about the fasting and starvation. What will be the various metabolic uses and uh, what various metabolic changes occurs when we are in fasting and starvation. Today we are going to talk about that. So in the fasting and starvation, the majority of the fuels will be directed towards the brain and the RBC, and there will be the uh, excessive purpose of the decrease in protein use. So the maximum amount of energy will be directed towards the uh, brain and RBC, and the degradation of protein is kept to the minimum. So your degradation of protein will be done at the last. So first of all, I want to know that the 1 gram of carbohydrate or protein will gives 4 kilocalorie of the energy, whereas the 1 gram of the alcohol will give 7 kilocalorie, and 1 gram of fatty acid will give 9 kilocalorie of the energy. So similarly, in the fasting and starvation, first metabolites to be used is carbohydrate, and after that is fat, and after the fat the proteins are used as the last as the metabolic fuel source. So first of all, let us discuss what happens in the fed state, what happens after the meal. So after the meal, there will be glycolysis and aerobic respiration. The insulin will be secreted abundantly after the meal, and this insulin will stimulate the storage of the lipid, protein and glycogen. So in the fed state, there will be the glycolysis, there will be the aerobic respiration, there will be the secretion of the insulin, and this insulin will stimulate the storage of lipids, protein and glycogen. So now let's discuss what happens during the fasting. So what happens during the two meals? So for example, if we eat one meal at the 8 a.m. in the morning and another meal at the 8 p.m. at the evening, so what will happen during the fasting period? So during that fasting period, the major energy source will come from the hepatic glycogenolysis, and others will be hepatic gluconeogenesis and adipose release of the free fatty acid. This adipose release of the free fatty acid is the minor metabolism that occurs during the fasting periods, and there will be the release of the glucagon and epinephrine, which will stimulate the use of other fuel reserves in our body. Now let's discuss what will be the metabolism in the starvation, like in 1 to 3 days. So in the starvation, in first 1 to 3 days, the maintenance of the blood glucose is done by the hepatic glycogenolysis, the adipose release of the free fatty acid. The muscles and the liver will use the fuel used from the glucose to free fatty acid. So there will be the decreased amount of the glucose in our body during the starvation. So the fuel used will change from glucose to free fatty acid, and there will be the hepatic gluconeogenesis. And what happens, the glycogen reserves will be depleted after the 1 day, and the RBC can't utilize the ketones because they lack mitochondria. So RBC can't utilize ketone once there is production of the ketone. So what will happen after the starvation, after the 3 days of the starvation? So after the 3 days of the starvation, from the adipose stores, ketone bodies will be released. So ketone bodies becomes the major source of the energy for the brain, and there will be the depletion of the adipose tissue stores in the various peripheral tissues. So what happens after that? When there is depletion of the adipose tissue, the vital protein degradation will be accelerated after 3 days of starvation. This may lead to organ failure and death. So the amount of excess stores that is present in our body determines the survival time of the starving person. So here I have discussed about the fasting and starvation. What are the various metabolic changes that occurs during fasting, starvation and well-fed states. So I hope you understood this lecture on the fasting and starvation. So this concludes our topic. Thank you.